Hey everyone, this is Miss Reese, and we are going to be going over the Unit 4 Edpuzzle test here. All right, so in our first question, we are trying to simplify each of these ratios. So as you're doing this, you're going to want to Google Desmos Scientific Calculator. You will need to use this as we're working on the test. And it should look just like this. You can also download the app on your phone, Desmos Scientific. So I'm going to be using the scientific calculator just off to the side here, so I'm not flipping between both of the screens. And so in our first question, we are looking for ratios that are similar to each other, ratios that are equal. So basically I can look at 9/3 on my calculator here. I can go ahead and divide 9 with 3 and see that it simplifies to 3, which would be the equivalent of 3/1. So I'm going to match those two cards together. Okay, 15/45. We type that into our calculator, 15/45. That simplifies in fraction form to 1/3. So you got to push this little button here to make that back into a fraction. So then we should have 1/3 here and 15/45 grouped together. We've got 20/60. That's going to be 1/3 as well, so I can place that here. And 33/11 is 3. We've got our two groups here. And then our last group, we should make sure all of these are equivalent. So let's type in 15/10 as a fraction. And let's also type in 27/18 as a fraction. And then they all equal this 3/2 as a ratio. So we can group these together. So you're really just looking for ratios that are equal to each other. We call them proportional. Right, in our next question, we are looking at a story situation, and we are putting these in ratio format and putting them in simplest ratio format. So we are looking for the ratio of glazed to sprinkles for the donuts. So we've got 120 glazed and we've got 80 sprinkles. So we want to simplify that first. So glazed to sprinkles would be 120 divided by 80. So we want to put that in simplest fraction form, which would be 3/2. And then sprinkles to total donuts. Well, we would need to figure out the total number of donuts. So we'd add our 100, 120, and 80. We have 300 total donuts. And we are comparing sprinkles to total. So sprinkles is 80. And so that would be 80 to the total, which is 300. And in fraction form, that would be 4/15. Okay, here we have a cross product. So we're going to multiply 2 with p minus 9. So I'm going to multiply that as a cross product. So it can be 2 multiplied with p minus 9. And then we're going to set that equal to the other cross product. And it doesn't matter the order. You could have done the 16 and the p plus 5 first. That's our first step when we see a proportion like this. Then we want to rewrite it after we've distributed. So that means 2 is going to multiply to p. That's going to be 2p. 2 is going to multiply to -9. That's going to be -18. 16 will multiply to p as 16p. And 16 will multiply to 5. And that would be 80. So from here, so I can show kind of the work for you, I'm going to put the rest of the work on this scratch pad. So we've got 2p minus 18 is equal to 16p plus 80. So we would need to, from here, put all of our p's, our variables, on one side. I'm going to go ahead and subtract a 2p on both sides. 2p minus 2p is going to be 0. So this is going to leave us with a -18 equals 14p plus 80. And then we would need to subtract the 80 on both sides so that we have all of our number terms on the other side. And when we do that, we should get -98 is equal to 14p. So our last step would be divide by 14 on both sides. And that should give us p equals, not x, so our variable is p here. So we would need to divide negative 98 with 14, and it would be negative 7. Okay, here we're looking for an enlargement or a reduction. So when we have an enlargement for a scale factor, that is a number that is bigger than 1. A reduction is a number less than 1 but greater than 0. Okay, so 4.5, that is greater than 1. I'm going to put that with an enlargement. 3 is also greater than 1. Put that with an enlargement. I know 0.75, that is less than 1 but greater than 0. That's a reduction. And then for the last ones, if you want to put them into the calculator here, 1/3, 0.3 repeating, that's a reduction. Or 5/3, that's 1.6 repeating, or 5/3. That would be an enlargement, 1.6, bigger than 1. And then 7/8, our last fraction here. 7 divided by 8 is 0.875, and we're going to put that into the reduction. So enlargements greater than 1, reductions between 0 and 1. Here we're looking for missing sides of our new figure based on our enlargement factor, our scale factor of 1.5. So on the first side, we've got 8, and we're going to match that up with this side here, DE. So we're going to do 8 multiplied with 1.5. That's going to be 12. Then for EF, we're going to do, EF matches up with this side here, that's 10. These are in the same relative position. So we're going to do 10 times 1.5, 15. And then our final side, we are going to take our 14 and we're going to multiply it by 1.5. And that's going to give us 21. And that's because these two sides, I'll highlight them red, these two sides are in the same relative position and match up with each other. Okay, here we are going to match up the sides again. We have our scale factor this time of 0.5. So we're making this figure smaller. So the first side that we're looking for is KN, and KN is this side here. It's going to match up with the red side. And the reason is because it's between those same congruent angle markings, the 1 mark and the 3 mark in the angle. So KN, we're basically going to take 14. We're going to multiply it by 0.5. So that's going to be 7. For RN, here's RN. That's going to be our blue side matched up. It's between the angle with 1 mark or 2 marks and 3 marks. So it matches up with this blue side here. So then we're going to need to do 21 multiplied to 0.5. And that's going to be 10.5. And then our last side is the green side. That is matching up with side length DS. So these two sides are in the same relative position. So we could take 42 and we could multiply it with 0.5. And that's going to be 21. Okay, here we have our coordinate points. We have a scale factor of 3/4. So we're basically taking each of these values and multiplying them by 3/4. So we're going to do -4 times 3/4. We also need an 8 times a 3/4. So our first coordinate is going to be at -3, 6. And our next coordinate, we're going to multiply 4 times 3/4. And then a 6 times 3/4. That's going to be 3 and 4.5. And then our last coordinate here, C. Anytime we multiply 0, that's just going to be 0. 0 times any number. Whoops. And then -4, we've already multiplied that out, and that's going to be a -3 here. And this is 3/4. 3/4 is less than 1. That is a reduction in the figure. K is less than 1, our scale factor. And when you're graphing this, we would have a point at 1, 2, 3, 1, 2, 3, 4, 5, 6. This would be our new point for A. This would be our new point for B, and then here would be our new point for C. So when creating the graph of that, you just want to make sure that the images, the shapes, look similar to each other. So that's what makes them similar, the same shape. Okay, and in our next figure here, we have 3/2. We're multiplying that with -1 times 3/2. And then we're going to multiply 4 times 3/2. So we will have our first coordinate at -1.56. Our next coordinate, if we multiply 1, that's just going to be 3/2. So our 1.5 is the same value. It's in a decimal format. And then let's multiply 2 times 3/2. It's going to be 3. And then for S, we just multiplied 2. So that's going to give us an answer of 3, -3. And then our final coordinate, when we multiply anything with 0, it's 0. And then the -2 will produce a -3 as the answer. And because this is a 3/2, that's greater than 1, that's an enlargement. And then if we just want to do a little sketch of this graph to make sure it does in fact look similar. So -1.5 and then 1, 2, 3, 4, 5, 6. And then we have a point at 1.5 and then 3, 1, 2, 3. We have a point at 3, -3. And then we have a point at 0, -3. And then just connecting them and making sure that the first quadrilateral that you have looks similar in shape to the other quadrilateral. There we go. Okay, so here we have highlighting the sides the same color that match up with each other. So I've got my 2 blue sides, and then we've got we can use any color, 2 red sides here, let's say. So when we're creating ratios for this, typically I'll do like blue over blue equals red over red. So create a ratio blue over blue, and then the same ratio here for red over red. So that's going to be this first ratio. 12 over 2x plus 22 equals 14 over 56. So that means when we multiply, we're going to get 12, or I'll do the 14 with the 2x plus 22 first. And then we'll equal that to 12 multiplied with 56, the other cross product. We're going to rewrite that after we've distributed. Okay, so 14, we're going to multiply that with 2. And that's going to be 28. And then we're going to multiply 14 with 22 instead of just 2. So that's going to be 308 equals, and then we need our 12 multiplied with 56. Oops, 12 multiplied with 56, and that's going to be 672. So now if we write this out here on the side, the first thing we would want to do is subtract 308 on both sides. So 28x equals, so I need to subtract that 308. So we've got 672 minus 308, and that's going to be 364. And then our last step would be to divide by 28 on both sides. So that 364, we'll divide that by 28, and x would be 13. Okay, we have another similarity problem. This time the triangles are a little bit rotated around. So I'm going to say that KJ, that matches up with GH. So this side here that's blue, I'm going to match up with this side here. That would also be blue. So we could do something like blue over blue in the ratio. And then my two red sides, we've got 33, which is KL. So there's, or LK, first, second letter, FG is what that would match up with. So we've got over the red sides here. So if we look at the options for ratios, it looks like they are both starting with 33. So it'd be 33 over 22. Those are the two red sides, equal to x plus 14 over 28. So then we multiply our cross products. We're going to do 22 with the 2x plus 14 first. And then I'm going to do the 33 multiplied with the 28. So now we just need to multiply this out and rewrite it after we've distributed. So we're going to do 22 times 2. We're also going to do 22 times 14. And we're going to need that 33 times 28. We've got 44x plus 308 is equal to 924. Then we would just have to subtract 308 on both sides. So 924 minus 308 is 616. So my next step is going to say 44x equals 616. Then we would just need to divide both sides by 44. And x is 14. Okay, here we have another set of similar triangles. We have side length CE, first letter, last letter. That's going to match up with side length FG, or I'm sorry, FE. So these two sides, those will be the blue sides. And then we can do our red sides here. DE, that's going to match up with GE. So these two sides are going to be the red sides. So when we create a ratio, looks like we're starting with the 27. So I'd put 27 over x, blue over blue, equals 25 over 40. So now for cross products, you would do 27 times x, that's 27x. And then we would multiply out the 40 and the 25. Let's see, did I pick the right one? So I've got 27 over x. Oh, I should have picked this one. 27 over x, blue over blue equals red over red. All right, so that's actually going to be 25x equals, oops. Hopefully you noticed as I was doing that and you're saying, Miss Reese, what are you doing? We've really got 40 times 27. And then we would go ahead and take 1080 and we're going to divide that by 25. Oh, and I didn't show my cross products here. This was 27 times 40. So then we would get 25x equals 1080. And then x is 43. Okay, here we're solving for two variables. So I'm going to highlight the sides that are in the same relative position, 16 and 12. So those can go over each other in a ratio. Let's go ahead and solve for x first. So the sides that match up for x would be the 8 and the x. So we can create a ratio for both of these. So we could do 16 over 12, and then we are going to equal it to the 8 over x. So if we were to multiply our cross products, we would get 16x equals 12 times 8. The 12 times 8 is 96. So let me write this over here. Our next step would be 16x equals 96. Then we would just have to divide by 16 on both sides. That would be x equaling 6. Okay. And then for our y sides, we have a y and a 9. We can put them in the kind of the same order. So we still need to use our 16 and our 12 because those are two known sides. And then we're going to set that equal to y over 9. So if we were to multiply our cross product, it would be 12y. So I'm going to do this in yellow. 12 times y equals, and then we would need to do 16 times 9. That would be 144. And then we just divide by 12 on both sides, and y equals 12. All right, here we're looking at triangles, shortcuts for similarity. So the first thing we want to do is look at what are the ratios between the two smallest sides. So we have 3 sets of sides that we know in these triangles. So our 2 smallest sides, so 25 smallest side, in that triangle, 10, that's the smallest side. So I'm going to make a ratio for that, 25 over 10. My 2 middle side lengths, those would be 30 and 12. I'm going to put those in a ratio as well. And my 2 longest sides, we'll make those red. That would be 45 and 18. That's 2.5. So if you notice, these ratios all equal 2.5. That means these triangles have sides that are all proportional. So in the options of why they are similar, they have 3 sides that are proportional. That would be our reason. Through side, side, side. We just created ratios that all reduce to the same value. Okay, our next example here. Move this over. We've got a set of triangles that are connected at the center here. We know these angles in the middle are congruent to each other. So kind of 2 notes. We know anytime you see a bow tie problem where your triangle looks almost like a little bow tie, we're going to have vertical angles that are congruent. So I marked them in the center, vertical angles. So you're marking the angles in the diagram that are congruent. So we marked them here. And then we want the ratio of the 2 smallest sides. So 6 is the smallest side in this triangle, and 42 is the smallest side. And then our 2 longest sides, those would be 12 and 84. So we need to make sure those ratios are the same. So the smallest sides, let's do 6 and 42. And then our longest sides, let's do 12 and 84. And it looks like our numbers here are the same. Okay, so we have 2 ratios that are equal, and we have an angle in between them that's equal. So this would be the side angle side similarity shortcut. Side, side, side angle side, 2 sides, and 1 angle in the middle. Side angle side. If any of those numbers were not the same, so like let's say these decimals reduced to the different values, then they would not be similar. Okay, here, mark the congruent angles in the diagram. Well, these both have 69 degrees in them, so we know those are equal. I marked them in my diagram. And then we can say smallest side would be 15, smallest side's 26. So 15 over 26. And then my 2 longest sides would be 22 and 35. And if you notice here, these decimals are not the same value. So even though we have 1 angle that's the same, we don't have proportional sides. So these are not similar. Here, another bow tie question. So we have the vertical angles first that are equal. So I'm going to put a 42 here. And then I would need to use the triangle sum theorem to find this missing angle here. And I would need to use a triangle sum theorem to find this missing angle here. So do we remember the triangle sum theorem? How many degrees are in a triangle? 180. So I'm going to take 180 and subtract 53 and subtract 42. That's going to be 85. And then I'm also going to take 180 and subtract the 42 and the 85, and that's going to be 53. So the first problem that I wrote out, that was going to help me find this angle here, 85. And then my second problem that I wrote out, this is going to help me find this angle here, 53. So using the triangle sum theorem, I have some angles that are the same. That's one of our angle similarity, or that would be the angle-angle similarity. So angle-angle means that you have 2 angles in the triangles that are the same. And obviously, if you have 2 that are the same, the third one would also be the same. So look, we have 2 angles that are 53. We have angles that are 42. That would be enough. But we also have angles that are 85. So these triangles are similar because they have two angles that are the same. Here we're also going to use the triangle sum theorem. So let's take 180. Let's subtract 87 and 30. And then we also have 180. We're going to subtract 87 and 32. So when we subtracted 32, this angle here is 61. We found this angle here was 63. So the only angle that's the same is the 87. And we need two angles that are the same for these triangles to be similar. So we're going to say that these are not. And then our last problem here. This is another bow tie question. So we have our angles in the center here. We call those vertical angles. Those are equal. And we also have a mark on angle S and mark on angle L that shows that those angles are congruent. So we have two pairs of congruent angles, which makes these triangles similar because of angle, angle.